With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that in the following figure, all the surfaces are assumed to be frictionless and the pulley is assumed to be ideal. Now the block A is projected with towards the pulley P with an initial velocity u0. Then we need to check the correct option. The string would become tight at t equals to this amount of time, or the distance traveled by the block A before the string taut is u square by g. Distance traveled by the B before the string taut is 2u square divided by g. And finally, the common speed of the block just after the string taut is this n plus 2 divided by n plus 1 into u naught. We need to find this. We need to check which option is the correct option. Now here it is asked for the time when the string becomes taut. So what is the initial length? So let's say this length is given as to be Li, and let's say this would be let's say, or we can say that this is equals to L naught and this is equals to, we can say that L1, something like this. So the length of the string would be constant. So when we have projected this with a velocity u naught, this mass with a u naught, so string would be loose. When string would be loose, this B would be in the condition of the free fall. This would be in the condition of free fall. That means it would be an accelerating. It would be accelerating with an acceleration equals to g. So the distance is initially it was at a zero velocity. So what is the distance which is traveled by the B at any instant of time? It would be ut plus half at square, simple. Okay, or we can say that initial velocity is 0. So the displacement of the distance, because it is just a linear motion, so it would be same. So it would be equals to gt square divided by 2. Let's say this is our equation 1. Now in the same instant of time, in this t interval of time, what is the distance which is traveled by our block A? So we say that distance traveled by the block A, this would be equals to velocity into time or speed into time, because it is not having any acceleration. Now when the string would become taut, so the distance which they are traveling in the same amount of time, this should be equal. Otherwise what will happen? We know that the length of the string is fixed, L0 plus L1. Now if it travel different distance and it travel different distance, then the string would not remain taut. So the string to be taut, so if initial length is L0 plus Li, so the final length should be equals to L0 plus Li. So this would only happen when they both travel the same distance, this distance in t amount of time. So we can say that our SA should be equals to SB. Okay, so we can say that u naught t, this would be equals to g t square divided by 2, or we can say that our t would turn out to be 2 u naught divided by g. So the first option is the correct option. Now we need to find what is the distance traveled by A or B. So distance traveled by A and B, they both are same. So SA we just find u naught into t. So u naught into 2 u naught divided by g. So this would be 2 u naught square divided by g. So that means B option is wrong. Distance traveled by B would be 2 u naught square by c. This is correct because the distance traveled, these are the same distance. Okay. Now we also need to find what is the common velocity when the string again becomes taut. Now what will happen? Now since it is moving, okay, and it is accelerating, okay, it is accelerating. Now what will happen? So initially its speed would increase. It would be traveling more and more distance due to the increase in the speed. Now finally what will happen when the string would becomes taut? So it would be getting an impulse in this direction, okay, it would be slowed down, and it would be getting an impulse along the direction of the string. Okay, let's say the impulse is j, so it would be getting impulse in this direction, this would be getting an impulse in this direction. Due to impulse, it would be incorporating a change in momentum. Okay, and this would also be incorporating a change in momentum. Okay, how can we write the change in momentum for the block of mass small m? For mass, sorry, not mass small m, but mass a, what is the momentum? Momentum is change in momentum. Impulse is change in angular momentum. Sorry, linear momentum, pf minus pi. Now momentum we can write mass into final velocity minus initial velocity. So vi. Now what is the mass? Mass is n into m. This is the mass. What would be the final velocity? We say that they are achieving a final velocity v minus what is the initial velocity u naught. And the direction of the impulse, this direction is the positive. That is why we have taken u naught to be the positive direction. Okay, along the length. Now for mass b, we can see that what would be the velocity after just becoming taut. What would be the velocity since initial velocity is 0? So we can say that first of all we just find the value of the velocity. We can say that v equals to u plus of at. Okay, so initial velocity was 0 for our mass v. Then we can say that velocity at any t instant of time, this would be equals to acceleration into t. Acceleration is g, and time we have already calculated, 2u divided by g, 2u naught divided by g. That means the velocity of the block of B just becoming the torque, it would be equals to 2u naught. Okay, this would be the velocity. So what would be the change in momentum? So change in momentum would be equals to final minus initial. So it would be mass into final velocity would be the common velocity minus initial velocity is 2u naught. Initial, in this case, initial means just before becoming taut. Okay, so here initial means not this initial just before the string becomes taut, and v here means the final velocity. Now what is the direction of this velocity? We know that this velocity would be in the downward direction. Okay, that means we have taken downward to be the positive direction. Now impulse direction is in the upward direction. That means above direction would be the this negative direction. So this is equation 1, this is equation 2. If we just equate the equation 1 and 2, so we can say that nm v minus v naught, this would be equals to, here the j value would be minus m v minus 2 v naught, or this is u naught, sorry, not v naught, it is u naught. So this would be equals to u naught, and this is also equals to u naught. Okay, now simple, we need to find what is the common velocity v. So here it would be m would be cancelled, nv minus n u naught, this would be equals to minus v, and minus minus would be plus 2 u naught. If we solve this, then our this common velocity v would turn out to be n plus 2 upon n plus 1 times u naught. That means our D option is the correct option. N plus 2 upon n plus 1 u naught, D is the correct option. So the correct option are A, C, and D. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.